To understand relative frequency, you first have to understand what frequency is. So when we did the two-way tables, we said that the frequency was how often something occurs. Another word for frequency could just be number. So if it ever asks you to find the frequency of an event, just think the number of the event or how often that happens. So relative frequency is how often something occurs compared to all possible outcomes. So if you're comparing an event to all possible outcomes, you can write that as a ratio, and that's what we're going to practice. To determine relative frequency, you're going to first write a fraction with the frequency of the desired event as your numerator and the total number of data entries as the denominator. So in other words, you're going to have the event divided by the total. And remember, when we're saying total, that's the bottom right corner, the total box is the total that we're comparing to, because that is all possible events. So you've written your event over your total as a fraction. You can simplify the fraction if necessary. Then your answer can be written as a fraction, a decimal, or a percent, because any ratio can be written of one of those three ways. So just pay attention either to how you are asked to express your answer, if it's specified, or you can just write it in the method that you prefer. So let's look at this practice here. The table displays survey results to see how students and their teachers feel about a proposed new dress code at school. So I'm going to put total and total in my columns. And now we are given the number of students tallied as a frequency. So 25 is a frequency, 189 is a frequency, 8 and 263. So let's fill in the rest of the numbers as a frequency first. So if I look at this box here, if I have 189 students total and 25 were in favor, I can use reasoning to figure out 189 minus 25 would leave me with 164 students. Then I'm going to go to the in favor row next. So 263 are in favor. 25 of those are students. So using reasoning, I can do 263 total minus 25 students would leave me with 238 teachers. Then against, 164 students and 8 teachers are against. So in total, 172 are against. Then teachers total, down here I have 238 in favor and 8 against. So in total, that is 246. And then last, for my total, I'm going to add both ways to double check myself. 189 plus 246 and 263 and 172. Either way, I get 435. So remember that if you add up your columns and your rows and the numbers don't add up, then you've made a mistake somewhere and you need to go back and double check your answers. But always double check at the end. Okay, so everything we've done so far is just filling out our two-way table with the frequencies. What is the frequency of students who are against dress code? So I'm going to go to students, against, and I see 164. What is the relative frequency of the students who are against the dress code? Show how you found your answer. Okay, so I'm going to look at 164 is my frequency, and I'm going to divide that by my total. So remember, the total, 435 were surveyed. So if you want to just leave your answer as a fraction, you could stop, or since we find it easier to compare decimals, you could use your calculator and divide the numerator by the denominator, and that'll give us about 0.38. If I multiply that times 100, that is about 38%. So I'm going to go on my table, and I'm just going to write a slash 0.38. No, I'm not going to put a slash because that looks confusing. So 164 or 0.38. What is the relative frequency of teachers who are in favor of the dress code? So teachers in favor is 238. So again, my frequency is 238 divided by my total, which is 435. So use your calculator. And that's going to round about to 0.55. I'm rounding this to the hundredths place because I want to write it as a decimal and then a percent. So that'll give me, to the nearest percent, 55%. So I'm going to go ahead and put that in the correct spot here. Now, I do want to show you something. If we were to fill in the rest of the table with the relative frequencies, so just go ahead and do each one. 25 divided by 435, about 0.06, because that's going to round up. And then 8 divided by 435 is 0.02. Now, based on what we know about percentages, you know that your total, 435, is going to be 100%, or 1. So our decimals should all add up to 1. If I add 6 hundredths plus 38 hundredths plus 55 hundredths plus 2 hundredths, I get 1.01. Well, I know that should be 1 because it should be 100%. How am I getting 101%? You got to think about all that rounding you did. So each time you rounded up, anywhere that you rounded up, that's going to affect your total. So if that's the case, the way that you can check your answers is to check these total numbers here and then see where those rounding errors might affect your total. So I'm going to do 189 divided by 435, and that's about 0.43. Oops, a pen would be helpful. 43 hundredths. So you can see there's an example. If you added these two together, you would get 44 hundredths. But because we rounded one of those up, it doesn't quite add up. So then we're going to do 246 divided by 435. And that's about 57 hundredths. So that one actually works out. Oops, I did not mean to write a 0 there. And then see if you add here 43 hundredths and 57 hundredths, that would give us our 1 or our 100%. Then the the column there, 263 divided by 435 is 60 hundredths. And there's another example. If you added 6 hundredths and 55, that would be 61. So we know, I think it was the 6, wasn't it, that we rounded up? That's why it's affecting this column here and this row here. And then 172 divided by 435. I'll try that again. I did not get a reasonable answer. 40, rounding up to 40, and see that works in both this row and this column. Those are going to add up. So when you round something up, just know that there could be a little bit of a rounding error in your answer, but still go ahead and double check, and if you can find where that rounding up affects your total, then you can still be confident that your answer is correct.